Let's go. Clap.
That was your cue.
Yeah. Well, thank you. Thank you all so much for making it back from lunch. And I guess there should be candy bars here, for the people who make it first. Listen, we have a fantastic panel. I think a lot of the people here on the panel don't need any introductions, but I'll give you some tidbits about them. So at the social hour, you can accost them and ask them about it. So sitting to the extreme right is Francis O'Flaherty, representing Rivada. Fun fact about Francis, he has, 6 stitches in both of his eyebrows, each eyebrow. And so please go talk to him about it. I'll let him introduce himself, but that's a fun fact. I think one of the eyes involves a bunch of bulls. So sitting next to Francis is Mohammed Marashi from SES. And if you want to be a Zen master, you need to live at a height between 15 and 20,000 feet at Mount Kailash for 30 days nonstop. So there's our man. So Mohammed, pleasure. Thank you. Next to Mohammed is Jeff. Jeff Huggins from Skylabs, and his claim to fame is I think he has sailed from Newport, Rhode Island to Bermuda 7 times, the 636-mile. Of course, he's also fluent in Japanese, so gambarimasu. And next to Jeff is Tina. I think she's a regular here. I've seen her in Paris just a few weeks ago, I think. And Tina, talking about polyglots, Tina understands and knows Swahili, and I think she has taught herself Korean through subtitles. So, and finally, closest to me is Dr. Claire Martin, and I think she's a few continents ahead of all of us. I think by February of 2026, she would have visited all the continents. So that's a little bit about her. And please, at the social hour, go talk to them about their interesting stories. But rather than me tell them about their company and what they do, maybe I give each panelist 60 to 90 seconds to tell them, to tell you guys about themselves. So maybe we go reverse order. How's that? Claire? Yeah.
Yep, that's fine. Hello, everybody. Yeah, and I am ridiculously excited about my trip to Antarctica at the beginning of next year. That will be the 7th for me. So my name is Dr. Claire Martin. I am the Executive Vice President of Astroscale in the US. I like to confuse people with my accent, but I actually live in Denver these days. As Executive Vice President of the company, I have overall responsibility for anything that's related to delivery. So all of the engineering, programs, quality, and IT for some sins in a former life. Astroscale itself, we are a company that is dedicated to on-orbit servicing. We were founded back in 2013. We are actually a global company. Our holding company is in Japan. And we look specifically at how we can bring the technology of things like RPO, rendezvous proximity operations, and docking, and our satellite operations techniques into creating that logistics chain on orbit, into bringing on-orbit servicing to the space domain.
Good afternoon, everyone. My name is Tina Gator. I should make you all stand up and do a stretch or something, because I don't know about you, but there's been a lot of carb intake on my part this afternoon. I am the Chief Strategy and Revenue Officer for Aerospace Lab, the group. I also run our US subsidiary based out of California here. Aerospace Lab is a satellite manufacturer, very vertically integrated across payloads and all different types of satellites for telecom, EO applications, et cetera. In my role at the company, I have most customer-facing functions, so your typical sales, business development, marketing, program management, regulatory fell into my lap, and a few other things that no one else wants to touch. That's not core engineering. Solutions engineers belong to me too. So own a number, it's been exciting. I've been at the company 2.5 years. We are about to launch our 10th satellite on Transporter 15. Most of our satellites have been launched into LEO. We have a footprint across Europe, headquartered in Belgium, but also a footprint here in the US. So looking forward to the panel and any questions you may have.
I'm Jeff Huggins, and I run the U.S. piece of Kai Labs. Kai Labs has been around about 13 years. We're headquartered over in France, and shaping the light is what we're all about. And in the space environment, we are ground station providers. And the distinction about our ground stations is they're working on a routine, regular basis, connecting with satellites in orbit, bringing data down bidirectionally. We've got one in Western Australia. We're installing one in Korea. We've got them in France. We're installing in Greece. So they're out there, they're operating, and I guess the message is for those that are considering optical, it's here, it's available, and it's not just us. There's other companies, obviously, that are moving in this direction. The technologies are making it work and available, and there are a lot of people trying to come into the market. At any rate, I guess that's enough about Kai Labs.
Good afternoon. My name is Mohammed Nourashi. I'm the Senior Vice President of Future Business and Innovation at SES. And I think most of you are probably familiar with SES, but if you're not, it's a global satellite provider. And they just went through a merger with Intelsat, so that they've been around for 60 years. Actually, this merger of SES and Intelsat, it includes Loral, PanAmSat, O3B, GE Americom, and so all those companies over the years consolidated to now what we call SES. My role is really looking at what we call our fourth pillar of strategy, which is focused on diversification. So I'm not focused on the broadband aspect, but all adjacencies to that. It's part of expanding the portfolio of products that SES offers, as part of also de-risking the business. So I look at things like direct-to-device, quantum key distribution, and we'll discuss some of those a little bit later.
Francis O'Flaherty. I am a managing director with Rivada Space. We got into the space business at the end of 21, beginning of 22. We actually started the company 20 years ago providing private wireless networks, primarily for federal agencies, emergency response and disaster response. And it's interesting because back then, when we would go in and set up what was essentially, commercial off-the-shelf network, backhaul was always satellite. It was the only thing available. And here we are 20 years later, where that satellite and space element is now becoming, rather than serving the network, it's becoming the network. So Rivada Space is a US company. We've operations in Europe as well. A lot of our engineering happens out of Germany. And we are building a super secure private network, essentially, that doesn't take advantage or doesn't make use of any ground stations. So completely independent of any terrestrial fiber networks. And it offers secure global point-to-point communications for a niche market, primarily governments, high-value enterprise.
So thank you, all of you. And I'll introduce myself a bit formally this time. I represent Cambridge Consultants, and this panel, as you can tell, is about deep tech. And each one of the panelists is doing something phenomenal, looking forward. I'll tell you about how we define deep tech. We at Cambridge, headquartered out of Cambridge, UK, we have been doing deep tech for 60 years. And to us, deep tech means looking at a problem around the bend. So looking at technologies 2 to 5 years out, leveraging either fundamental physics or mathematics or molecular biology, or so storing things in DNA or beamforming from the stratosphere, a variety of such things, and a track record on deep tech for the last 60 years. On an average, every 4 days we file a patent, and we file a patent on behalf of our customers. So we have been creating what is called sustainable moat for our customers, and that's really what we do. So given, each one of you described a little bit about deep tech. So maybe I come back from you, Francis, back towards Claire. You mentioned that Rivada is building this novel architecture, novel satellite architecture without any ground stations. Tell us a bit about, the deep tech part of it, what technological innovations you had to do to, get where you are and where you are in your journey.
Sure. Yeah. So one of the things that becomes very apparent very quickly when you aren't using ground stations is the necessity to intelligently route that traffic in space. So using the satellites rather than just a mechanism for transporting data to actually change the way that data is manipulated and even processed on the satellite. So there's a lot of innovation around processing essentially at the edge of space now and routing that traffic to where it needs to go to. So we think about, I guess, deep tech as a combination of the various advances that are going on in intersatellite links and the optical networks that we're using to route this traffic, combined with various AI programs that we have, not just at the satellite level, but also to support and modernize and make optimal use of the ground systems that we use and all the elements that go into the supply chain, for example. We outsource all of our manufacturing. So managing all of those entities and making sure that we're taking advantage of the latest innovations in tech to make sure everything gets delivered on time and as cost effective as possible. And then the operations of the network as well, making sure that, as I mentioned, the transport of that data and moving from the network purely as a means to just transport that data around the world to make it much more intelligent and meet the user's requirements. And also the issue of digital sovereignty comes into it, and that's a big thing for us, and it's one of the reasons that we decided really from the very first principles to design a network and architect the network without going through ground stations and just reduce that possible threat level, if you like. So we're taking advantage of various advances in deep tech in a whole range of operations right across the company, from the planning stage, supply chain, manufacturing, and then operations of the network as well.
Thanks, Fran. Mohammed, first of all, congrats on that SES-Intelsat merger. I think now it's formally closed. As a guy who has future in your title, right? You're thinking about the future, right? Maybe you can tell the audience, to the extent you can, how A, this merger strengthens both sides, and B, what is next for you? So what are you looking at that's around the bend?
Okay. So let me sort of break that down into two different segments. First of all, we are 3 months into the merger, acquisition. And what I think is going on is, and this was really important from our customers' perspective, our ability to serve them better. And just to give you some examples of what we're doing. So for example, on the media side, we now have 9,500 channels that we're distributing. And we are providing, some of the 10 top sports events that are being viewed by over 2 billion people worldwide. We now can serve 8 of the top 10 MNOs in the world. And we're serving 30 commercial, in commercial aviation, we are serving 30 airlines, and we are the largest provider of capacity for the airlines in terms of raw capacity. So these are obviously benefits that come to our customers. And on the government side, we are serving 60 plus agencies and institutions now in over 30 countries. On the deep tech side, the interesting stuff that's going on, and I mentioned it a little bit earlier, is on the quantum key distribution. So quantum communications is one of the areas of interest, and quantum key distribution is one of the first use cases. And this is a project that we've been involved in as part of the ESA program, the European Space Agency. We are the prime. We've been working with 20 different partners on the development. And quantum key distribution prototype, which we call Eagle 1, is being launched next year. So this is not theory anymore. It's actual technology, even though I would call it bleeding edge technology. But it is within the quantum communications, really the first application that will be tested from a European perspective. I know the Chinese have done testing in the past. So we are very excited about that. And this will be, ground terminals are already being upgraded and deployed across Europe in order to do the testing next year.
Very cool. And Jeff, as in the optics world, I think you're solving some fairly gnarly problems. I can understand ISLs, but when you try to get data space to Earth, that's a hard problem given weather and other constraints. So to me, it sounds pretty deep techy what you're doing. So tell us a bit more about what roadblocks there have been in the past, how you overcome them, and you said the time is here and now earlier in your introduction. So tell us a bit more about that.
Yep, I'm believing it's here and now. So everybody involved in satellite communications, myself included, is RF experienced, and that's what it's all been about. And I've been looking at PowerPoints that talk about free space optical communication for 20 plus years, and they've all been about one PowerPoint deep. But the exciting thing is, because of some deep tech innovation, it's reality now. And one of those deep tech innovations is the ability to move data between satellites with optics. And so low latency, you can move it between the satellites to find a sunny spot to come down. And the other one is something that our company specializes in, which is trying to get it through the atmosphere. And as I mentioned in my introduction, we're doing that on a routine and regular basis now. There's actually two technologies. We've got one that we think is better, but adaptive optics is the legacy one that people are working on to punch through the atmosphere, and ours is MPLC, MUX and DMUX process that comes at it from a different angle based on some telecom principles. But the important thing, I guess, to take away is that because of that deep tech that was there, we've now been able to turn that into a business model that works for us as a hardware provider and has obviously turned heads that people have put money on the table and are buying the optical ground stations, installing them, and using them now. So I guess that's the message I put out there is deep tech and moving all the way to a business model is where I feel we are right now, and welcome to expand our network.
You should talk to Francis after the panel. I think he's looking for somebody with ISL expertise. Anyway, moving on to you, Tina. I've heard you speak before here as well, and we met in Paris. One of the things you mentioned to me was, you first try the technology yourself. You try to make sure that it works for you, and once as a nimble, modular integrator / manufacturer, right? Once it's ready and mature, you then offer it to your customers as well, right? So, given your vantage point, what is sort of in the near future for you, and what's in the far future for you? Like, what are you looking at next? Yeah.
That's a really good question. I'm actually very glad to be sitting next to Jeff here because I spent 3 years trying to get optical communications adopted in a prior life. So I'm super excited. Tim Deaver's in the audience, was on my team and my previous company. So anybody needs OCTs, that's a great company to get them from. So there's a plug for you, Tim. And maybe it's a little known fact, Aerospace Lab actually, through the acquisition of Amos and prior to that, has adopted key technologies, optical being one of them. We have probably 5, maybe 6 space-to-ground optical terminals on our birds right now. We've actually done testing with our own optical ground station as well as K-Labs, so we're excited that we're able to put light and data through some of these technologies that we've adopted, and that's kind of in our DNA. So we've looked at the problem statements a young company faces. We're only 7 years old when we try to go acquire subsystems and the like from some of the major players. You sort of get put in the back of the queue. And part of that, led our founder and CEO to sort of internalize a lot of the key technologies to really make efficient use of resources we have, people and money. So we're very vertically integrated, starting at the subsystem level, right away through to our platforms, through the payloads that we've built in-house. So electro-optical payloads of all different kinds. Take some really great fancy pictures in VHR, multispectral. We're launching the Ferrari of a hyperspectral payload very soon, I like to say. We've got RF sensing satellites where we built our own payloads. And all of this came from core expertise, but also we want to understand the customer's mission, and we don't want to have to squeeze your payloads onto what we call, or what we hear industry call, standardized platforms, because what we've focused on is the technology stack that turns into subsystems that have some room to grow or become smaller. And that way the structure that gets wrapped around some of your payloads, or some payloads we provide, really is focused on your mission objectives. So that's kind of in our DNA. The other thing that we're very focused on is scalability. So that design process comes into our thinking right at the onset, because we want to build constellations of all different sizes, because I think that's where you can achieve economies of scale. So deep tech to us means a lot. It means everything from the technology stack into the vertical integration, into thinking ahead in terms of some of the tool sets that we've adopted as a young company, the great ERPs and the MRP systems that we're able to adopt, where large companies are probably not able to pivot that quickly into some of those things. And the fact that we quietly deploy these, put in-orbit demonstration missions, and then only do we go out there in the market and try to sell those to our customers. So most of the time, our tech is proven, TRL 9 or very close, before we are pitching it to our customers. And I think in about 2 years, we'll be almost 90-some% vertically integrated at the satellite level, down to our own solar arrays, which we experienced difficulties from a price point and supply chain a couple of years ago, down to our own EP, where we were buying EP and electric propulsion, that wasn't quite up to the spec. So we've internalized that, and we'll be flying both of those on a mission next year, customer mission next year.
So not only are you drinking your own champagne, you're first making your champagne.
Indeed.
Then drinking it. So I like it. I like it.
Of course.
I like it.
Of course.
Thank you. Claire, as a kid, somebody had given me this book. It was a hardcover book on the Apollo-Soyuz mission, right? I don't know if any of you remember. I'm really that old. But the fun part about the book was that how these two systems made by two opposing countries at the time, it was Cold War era, they would come and they dock with each other, right? And to me, that was magical. And you do this on a daily basis now, right? So as you're thinking about in-orbit servicing, take us a bit on the journey from back then to now. Like, how mature is it? How fringy it is? Maybe that's not an English word, but you think it's ready for prime time, and tell us a bit more.
Yeah, no, absolutely. Right, I think in contrast to Tina, though, I'm just drinking the champagne.
Okay.
Because we're not very vertically integrated at Astroscale.
Good news for me.
Okay.
Sell to you then.
Yeah, no, we can team up here. Yeah, you make it, I'll drink it.
Yeah.
So what we I was thinking back to the question when you asked the question, and I was like, when did I first get involved in anything related to on-orbit servicing in my career? And it was about as long ago as the one PowerPoint deep optical comms. Right, so I think it was the early 2000s when I first got involved in an on-orbit study. And we have come a very long way since then. We now actually have missions in build around the world towards on-orbit servicing, and interestingly, across all of the sectors of the industry. So we have civil agencies. A great example is JAXA and the ADRAS-J mission that we did. And now there are missions going on for civil agencies in Japan, in the UK, in Europe, and in the US. We're starting to see commercial operators of large constellations and fleets of spacecraft think about how they can factor on-orbit servicing into their planning going forward and the benefits it brings. And then next year, we will be refueling Space Force assets above GEO, transferring hydrogen to them. So as we sort of look forward, we need to push on the technology side, but also adjacencies to the technology to truly enable the on-orbit servicing business. So we have the basic technology building blocks now. We do have a very robust and well thought out roadmap for our technology going forwards, but we don't need to wait to achieve all elements of that roadmap before on-orbit servicing can become more routine. The technology itself is being proven by current missions now and by ones that will launch in just the next few years. And what we need to pair that technology innovation with is actually the conversations that we're starting to have around the policy and regulatory aspects as well. We need innovation in that area. And then we need to bring those aspects together into new business plans and ways of thinking about how we use the space industry going forwards. So we focus a lot on those three pillars within Astroscale. The technology is incredibly important, and all of our engineering, because we're not vertically integrated, is focused on the elements that turn a satellite into a service vehicle. But we also need to focus on our policy and regulatory work and on the economics to bring in this new space age.
Thank you for that. And as you can see, we have a mix of, I think, providers and then a couple of operators, and they're all doing deep tech in their own unique way. Just a shout out, I see a couple of questions beginning to come in. Please, I do have time allocated towards the end for questions, so please get onto the app and send us a question. Maybe I'll divvy up, and my next question is more towards SES and Rivada, and it's more about AI. So perhaps, Mohammed, you talked about QKD is one of the things, but a panel on deep tech is not complete without discussing AI to some extent. So on the AI front, the world is now talking about Business 5.0 and Industry 5.0, right? So if you sort of go back, we had manufacturing as sort of the Industry 2.0, the electronics and IT, and then Industry 4.0 was mostly about IoT. And now people are talking about AI ushering in this AI 5.0. Right. So where is SES in that journey with AI? How deeply are you embedding it inside? What are you doing with AI?
So I would say, I would put them in three different kind of buckets in terms of talking about AI. Maybe from the simplest to the more complex. On the simple side, it's getting more productive. Departments are using it, human resources, just doing things a little bit better, faster, whatever. So that's going on. I think that's already happening. The second is actually using in some of our services. So we're currently using machine learning capability in our commercial aviation, where minute by minute we are taking data in terms of latency parameters, the amount of data used to optimize the network effectively. And we do load balancing using that capability. We also have on the maritime side, on the cruise, with one of our partners, where they have AI embedded in one of their systems, where we have multiple networks coming in from whether it's 4G, 5G coming in, Starlink, our network, mPOWER, and it's looking at deep packet inspection and all of those, finding the right network to support that, and translating that into what we call a quality of experience measurement. So that's sort of being used as well. So those are some of the applications that they're evolving as well. The third category, I think, would be further out and looking at doing things more on a constellation basis, across maybe constellations, where things like, maybe even spectrum sharing can become more viable interference mitigation types of applications. So that's a little bit further out, but it's something that also could be part of what AI can help support, really take advantage the spectrum that is available, especially on the narrowband side, but it applies across the board.
Very cool. Thanks for categorizing the answer into those three well-defined buckets. And Francis, I would contrast you a little bit from Mohammed in that he has a lot of legacy to preserve, and any AI adoption that SES would have to make sure that everything works with it, right? You have the luxury of starting from scratch, right? So how are you thinking about AI?
Well, it's not too dissimilar from what Mohammed just described. I mean, there's the obvious kind of low-hanging fruit, if you like, of productivity gains with operations and everything else. And then you move all the way up to the constellation, and I think that's the exciting part. So it's not just software-defined networks in space and intelligent routing, taking advantage of the phenomenal work Tina did in her previous life with those ISLs and the work that Jeff is doing now, but also making sure that we leverage other partners' technology as well, and the investment in deep tech and in AI that's gone into maybe avoiding certain, even in space, geographic routing that certain customers don't want to go near for various reasons, and then processing that data in space. And that's one of the things that we're looking at the moment. Our COO is here as well, and he'll probably kill me for going into this. But one of the things that I'm excited about is taking advantage of that possibility of doing a lot of processing at the edge in satellite, where it doesn't have to come back down, and you're delivering much better solutions and outcomes for your customers. I think inevitably that's where it's going to go, and you're going to see a big change in what the digital global infrastructure looks like because of the consequences of the investment in deep tech in space, and satellite will serve as a primary method of communication, of communication channels and solutions for some of those customers. So it's really enhancing the amount of capability at the satellite and moving from it becoming, I don't want to say a dumb terminal for backhaul, but just building in much more capability, much more meaningful solutions that will happen autonomously in space rather than having to come back down to the ground and go up and down, et cetera, et cetera. So that's one of the things that we're exploring heavily and that we're excited about.
Very cool. Yeah, and there was a talk earlier before lunch on the edge AI in space. I think some of you watched it, so it's very relevant to what you're saying. For Jeff, Tina, and Claire, I'll probably ask a different question, right? So because you guys are trying to solve a problem that is at the fringe, obviously it's cutting edge, right? Sometimes there's a chicken and egg. So for Jeff, in your case, right, you want the ground stations to obviously be upgraded to allow for the optics, and then you also want the satellites. Now there's obviously some existing legacy satellite networks that may not support, right? I mean, how do you, when you think about breaking that chicken and egg cycle, like how do you, does standardization get you there? What are you thinking about expanding the TAM?
So the chicken and egg concept has been there, and I think that because of Tina and Tim Deaver and others that have been working at it for several years to have the discussion and realize that because DTech has made the progress that it has, that you can think differently about an architecture. And so a number of players have done that. Started with, I'm not sure it started, but SDA has done it a whole bunch. They've put 360 satellites, more than that, on contract that all have a requirement to have an optical connection to the ground. And so you can look at that and say, there's the chicken or the egg, whichever you want to say, and there's a reason to have optical ground and support that. So it took somebody with vision. It took a lot of people explaining how deep tech can have an application. In this case, being able to communicate with the ground optically, that has moved it forward. And my thoughts are that it's moving forward. And we've got a whole bunch of optical ground stations on contract. We've recently just completed an integration facility where building adjacent to our current headquarters, it allows us to do 5 optical ground stations simultaneously for the factory acceptance test so that we can deliver faster to our customers. That's the main thing we're up against now, is just the production rate and the backlog, getting them kicked out the door to the customer, and we're working on that.
Very cool. So you're at a point almost where the deep tech becomes tech, right? Because that's where we want to go to.
And a profitable business model,
all right,
both for us as a hardware provider and for all adjacent parts of the industry that are building satellites, that are providing a service as for satellites, all sorts of different pieces. It's starting to make business sense.
Very
I guess
cool.
is what it amounts to.
Now, Tina, you sort of went in the other direction in your earlier introduction. You basically talked about, because Jeff's talking about standardization, right? When things are required in spec, everybody builds to it, and therefore the whole ecosystem takes off. You know, what you said earlier, maybe I misunderstood you. You basically said you want to go more vertically integrated, right? You don't want a single bus to be fits, you know, this size fits everybody, or you can take small, medium, large, and you got to make it work. So standardization, does it help you? Does it hurt you? I mean, from a differentiation perspective, what are your views on that?
Yeah, maybe I can clarify a little bit. So we obviously build, satellite platforms to fit certain volumetric mass constraints. So we're already doing that based on launch vehicle parameters and things like that. So if you call that adhering to standardization, we do that. Where we're focused on is at the mission objective of our customer, whether it's an RF sensing mission or it's a telecom mission for direct-to-device applications, or it's a SAR mission or an EO mission. Many of the times, manufacturers, satellite manufacturers, have gone out there and said, "Oh, I think I'm going to build a 2 kilowatt bus or a 4 kilowatt or something like that." And what we've said is, and by the way, we can only, accommodate a 20 kilogram payload or et cetera. What we've said is, why don't we just focus on the building blocks within the bus and offer some flexibility there, and then wrap a structure around it, still within the volumetric constraints of the launch vehicles. And like I said, we're about to do our 10th rideshare mission on SpaceX. So we do all of those things really well, but in most cases, some of the chicken and the egg situation comes into play when we've struggled to get hold of a particular type of tech that we've needed that will perform to its spec and not just a promise. And so some of those things is what I was talking about that we've internalized. In terms of optical, I hear you. I was trying to sell optical communication terminals and as well as optical ground terminals, and it was like, well, do we have enough OCTs out there to warrant the adoption of optical ground terminals? And now I'm at a company that polishes is sophisticated, large 70 centimeter and above mirrors, and that takes time, people. So the production issues that K-Labs and others who want to buy OGTs from us, there's a timeline associated with getting these precision telescopes, to a standard, polished. And getting through that. The real chicken and egg thing with us is we've stuck our neck out there and are building one of the largest factories for satellite manufacturing in Europe. Decision was made before me, but I have to fill it. So that's kind of the chicken and egg question that I ask myself: is there enough business for the different types of satellites that are going to be solving real problems, whether it's telecommunication problems or EO problems. And our factory in Belgium is going to be one of the largest. And so is there enough business globally to put there? So that's kind of my chicken and egg, because you can't wait to say we're going to launch a constellation and say we don't have the capacity for it. So we took the risk of putting out the capacity and making a bet on the future business globally on the telecom side. So that's my chicken and egg.
Awesome. And Claire, clearly, I think your world also benefits a lot from standardization. As things get standardized, you can probably dock better. You don't want to build a custom solution for every legacy satellite that is out there. How are you playing with or driving the standardization to make sure that this becomes tech in the future and not remains deep tech?
Yeah, I think at this stage of the evolution of the market, we're actually being very deliberate in remaining fairly agnostic on the interfaces. So we have our own in-house. We partner with others. The focus for us now is making sure that we find the right solution for our customer's problem. So if it is like a legacy system that never necessarily anticipated using an on-orbit service, then we look is there a common feature of the bus that we can use to enable the service. So the launch adapter ring is a great thing that we are using for our GEO life extension vehicle. Wasn't put there deliberately to help us for on-orbit servicing, but it offers the opportunity for us to use it to enable the solution. And then for systems being designed now, it can be as simple as just thinking you might need something in future. So I put on a very simple docking interface, which will make the provision of a solution easier. And we're starting to see, a little bit like Jeff said, certainly from the government side, RFPs coming out where they're asking for things, for example, to be refutable. Put the interfaces on there now. Doesn't necessarily mean it will be used in the future, but with a little bit of advanced work now, it enables things to be done much easier down the road. Now, ultimately, I think we will get to just a small number of common interface standards, but it will be the market that drives us there to which standards we pick up.
Very cool. Thank you for that answer. I do have a question, a rapid-fire question towards the end, but I want to take some of the audience questions. And we have a question, I think the talk before lunch or the one before that was talking about, the Mars rover had a 2 megapixel camera and still working on the PowerPC chip because the design specs were frozen in '98, right? So I just remember that from the talk. When you're looking at very, very rapid exponential pace of innovation with deep tech, how do you reconcile the SATCOMs industry with these really long, critical design reviews and freezing things 2 years before anything even goes up in the sky, right? So any of you want to take that?
I think it's what I'm fascinated about is, we're trying to, I love the fact that we're going to be refueling, and I was looking at that a decade ago myself, but we're also trying to, the promise of LEO was agile innovation, 3 to 5 year lifetime. That's all we need, and then, let's replace them to keep up with the technology life cycle. So I think, as an industry, we're a little conflicted. We want to be good citizens and make sure we're clean up there and take care of space debris and refuel and all the things. But we also want to innovate. So we, for example, are really focused on trying to use, triple E parts from, the automotive industry and up qualifying them for the radiation environments. But, we put up, satellites within 12 months, right? Payload satellite integration delivered to launch site. And we're going to keep doing that because I think we have to keep the eye on the customer need. So as consumers, we're always consuming more, and that's not going to stop, right? So that's, I think, the conflicting feelings we all have in this audience and beyond is no more space junk, but at the same time, we want to innovate. Technology cycles are 2 to 3 years, so we should keep up.
Yeah, I think we're conflicted a little bit about which orbital regime as well, because you can drive that pace of innovation to low Earth orbit with the cadence and the affordability that you can get there with launch. You can't really with GEO. So that kind of pace of innovation when you're facing the launch costs and the insurance costs of running a GEO satellite, it makes you look at the business plan a little bit differently. So there definitely isn't a one-size-fits-all. I think it really depends on what your application is and where you're trying to go as well.
Yeah, and I mean, that question certainly resonates, the frustration between locking a design freeze and, making sure you take advantage of the most recent innovations in the industry. But if you think of it from our perspective of building a global data communications network, and you think of what the alternative is, because one of the ways that we like to think about this is it's essentially replacing that MPLS fiber network on the ground with a network in space. Can you imagine the amount of investment and time it's taken to build that global network of fiber versus what's been done right now in a very short period of time and space. And obviously Starlink is the obvious example of what's up there now, but a couple of others that are nearing fruition. I mean, it's phenomenal to think that has been done in such a quick time frame. So while it is a constant kind of source of tension, it's also really, really impressive to think of the advances that have happened in a relatively short period of time in satellite, and the continued advances, which will only going to accelerate given the amount of investments that go into this. I think that's something that everybody in the room can be very, very excited for and very optimistic about.
So I think we're going to run out of time soon, so I do want to ask a closing question to all of you, maybe just a one-sentence or two-sentence answer. Imagine this is 2030, we are still at the Silicon Valley Space Week, it's still October, and we've had good wine the day before. What is it that you would like to tell the audience, 5 years from now? Let's go from you, Fran, and just work backwards.
I'll be quick. I mean, we're at 2030. I'm hoping that we have a global network to manage, but I think that network will ultimately be effectively pretty autonomous. It won't involve too much monitoring, control, command from the ground. It'll be delivering a lot of deep tech solutions to the customer base that we think of.
Cool. Mohammed?
So I would like to be able to talk about the implementation and execution and the success of some of the things that we're talking about. Quantum key distribution is now, we've got what we call Eagle Next. It's providing services to the 3 segments that we're targeting, from banking to critical infrastructure to government. Also seeing success in our Meosphere constellation, which is our next generation Meo, and in direct-to-device.
Cool. Jeff?
So I guess what I would envision is tapping what one of the speakers talked about earlier, the 3 billion people that aren't connected right now, that in 2030 we've got an optical and RF combination network that taps into all that innovation that's not connected right now and is tapping into all that data and making more deep tech happen.
All right. Tina?
I'm really excited about, graveyarding the LEO versus GEO story, because I think now multi-orbits are accepted. What I'm excited about in 5 years is to see how the terrestrial telecom players are going to either dominate our space
or not exist
at all. So let's see what happens there.
We don't have time for that question, but yeah. Claire, 5 years.
5 years. On-orbit servicing is just tech. It's not deep tech. And you're sat there challenging me on how far we've had to reach into our roadmap to be able to scale to meet demand.
Brilliant. I love it. With that, please join me in thanking the panelists.